Now let's take a look at Gold Crew Firefighting Agent demonstrated in laboratory conditions by Dr. McNeely, formulator of Gold Crew products.
Oil and water don't mix. I shook together, in this illustration, 30 milliliters of oil and 30 milliliters of water. You can see the black gunk or mess sticking to the sides of the glass and the separated water at the bottom with the oil reforming a layer. Now, repeat that experiment, but this time I'm going to add 2 milliliters of Gold Crew Firefighting to the water before I add in the oil. Now, Gold Crew FF mixes very readily with water. Now I'll add the same 30 milliliters of oil to this dilute Gold Crew FF solution. Again, I'll shake the mixture, and this simulates the action of a dilute stream of Gold Crew FF coming from a fire hose and striking the surface of petroleum. Now, you will notice in this a brown emulsion, and notice that the oil is no longer sticking to the side, since it now consists of tiny droplets, each surrounded by a continuous phase of water. An oil fire burns above the surface of the petroleum. It burns on a mixture of the vaporizing petroleum and air. Now, this is a blow-up of a tiny microscopic droplet of oil in a Gold Crew FF emulsion. In order for the vapor to get from the oil to the air, it must first dissolve in the surrounding film of water. But oil is very insoluble in water. Then the water containing this minute quantity of oil must slowly migrate to the surface before the oil finally can vaporize to support the fire above. A Gold Crew FF emulsion dramatically decreases the evaporation rate of a petroleum fuel into the air. This starves the fire, and the fire goes out. I'd like to show you what happens when we drop or pour this mixture of oil and water into 1,000 milliliters of water. You will see we get what we expect, coarse drops of oil coming back to the surface and rather rapidly forming a film or layer of oil on the surface of the water. Next, I'd like to compare this with the Gold Crew FF emulsion of oil and the same amount of oil and the same amount of water. Pour this emulsion into water, and you immediately see the brown plume of tiny microscopic particles of oil spreading throughout the water layer. This demonstrates the emulsification by Gold Crew FF. Some time ago, I made up a similar emulsion with 30 milliliters of oil and 30 milliliters of dilute solution of Gold Crew FF in water. The tiny droplets in this emulsion, being lighter than water, gradually migrate toward the surface and form eventually a thick cream. Gold Crew FF forms a protective coating around each of these tiny oil droplets, which prevents them from coalescing with the neighboring particles when they get crowded into this emulsion. I want to show you that we still have an emulsion in this cream layer. I'll pour this again into 1,000 milliliters of water, and you again see the brown plume of the microscopic droplets of oil spreading throughout the water layer. Now, in the third experiment, I'd like to show you what happens when we pour just oil into water. I'm sure you anticipate the results. We see the very coarse drops of oil quickly coming back to the surface and they're coalescing into a thick layer of oil. Now I'd like to repeat this experiment, but this time I'm going to add first 20 milliliters of Gold Crew FF to 1,000 milliliters of water. Then we'll quickly mix this up. Now this forms a dilution of 50 to 1 of the Gold Crew. Now I'll again add the same pour the same thin stream of oil into the water. You will notice what happens. You immediately get the brown plume of the emulsion formed by the Gold Crew. Here, the dilute solution of Gold Crew, with just the small amount of energy from the falling stream of oil, is able to form an emulsion. In conclusion, these demonstrations illustrate the technical basis for the extinguishing of petroleum fires by Gold Crew FF. Gold Crew FF, as applied, has the ability to emulsify and stabilize a petroleum spill. Practical application of Gold Crew FF can protect petroleum spills from subsequent ignition and fire.